Welcome everyone to our webinar hosted by ICOLD, UCOLD, Low-Code, SANCOLD. My name is Janice and I have the honor of introducing everyone today and welcoming everyone to our webinar. First of all, we'll have Wilberforce who will be speaking about the dams in Africa. He is a dam safety engineer and he is also a board member of ICOLD YPF. Then there is myself who will be doing the introductions. My name is Janice Zhang. I am a civil engineer and I am part of the SANCOLD Management Committee as well as the SANCOLD YPF. After all the welcomes and introductions, we'll have Abebe. He is the chair of the Ethiopian Committee on Large Dams and the Honorary Vice President of ICOLD. He'll be giving us a presentation on the Nile Basin experience on the Dam Safety Capacity Building Program. Then we'll have Mr. Hattingh of Hattingh Anderson Associates. He is a private consultant that has over 31 years of experience in dam engineering, focusing on dam safety management and behavioral engineering. He is the immediate past chairman of the ICOLD Technical Committee on Dam Surveillance, as well as a co-opted member of the ICOLD Technical Committee on Dam Safety. He will be giving us the presentation on practical monitoring considerations. Then we have Matea, who is the chair of ICOLD YPF, and she will be giving us a short presentation on the YPF network. Before the presentations begin, we just have some house rules. Please may all participants have their microphones muted and cameras off. You're allowed to write any questions that you have in the chat box and we'll address it at the end during our Q&A session. And yeah, let's welcome Wilberforce to give us his presentation. Thank you.
Okay, thanks, Janice. My name is Wilberforce, as she said, and I'm giving a short presentation on some of the most interesting projects currently ongoing in Africa. The first one I want to look at is where I'm currently based, and that's the 600 megawatt Karuma hydropower project. It's right now at 99.9 project completion, and we're already commissioning the first 2 units, where currently one is already connected to the grid. It's a project that cost $1.7 billion with funding from Exim Bank and government of Uganda, and is implemented by Uganda Electricity Generation Company Limited. One of the most interesting aspects is the underground powerhouse and underground tunnels, which are over 25 kilometers. 2,115 megawatt Julius Nyerere hydropower project in Tanzania, with a project cost of about 2.9 billion, implemented by power company in Tanzania. It is going to be the largest power project in East Africa, and it has a concrete dam with about 134 meters high and 9 units, each at 235 megawatts. It has a main dam and also saddle dams. The other interesting one is Rusumo Regional Hydropower Project, which what makes it interesting is the tripartite agreement between Burundi, Rwanda, and Tanzania. This is a project owned by 3 countries, and each country will be taking 27 megawatts. The project progress is currently at 99, and it's being implemented by the Nile Equatorial Action Program, which is NELSAP, under the Nile Basin Initiative. It is funded by World Bank and the African Development Bank. There's also another interesting project, which is also going to be a tripartite agreement between Rwanda, Burundi, and DRC on the Ruzizi 3 regional hydropower project. It is still in its commencement stage. What I consider as the most interesting project at the moment is the rehabilitation of the Kariba Dam Rehabilitation Project, which involves the rehabilitation of the plunge pool and the rehabilitation or refurbishment of the spillway gates. As you can see on the downstream, there is a plunge pool which is clearly marked out, and also the spillway gates. But we will look more on how it is ongoing, which is in the next slide. This is the plunge pool on the downstream when it had been when the offer dam had been, if you can see on the downstream wall, and then the water had been pumped out. So right now, reshaping is ongoing, including the concrete works to protect the foundation of the dam. You also invited to Africa Hydro Conference, which will be in July, from 10th to 12th July 2023, and will be hosted in Uganda. Back to you, Janice.
Thank you so much, Wilberforce. It's always so exciting to hear about the current hydro projects that we have in Africa, as we all know that there's so much potential in Africa, and us as engineers need to do our best to make sure that these projects are optimized and they do go forth to help the communities around us. So next up, we have Michael Abebe, the chair of the Ethiopian Committee on Large Dams, who will be giving us his presentation. Thank you.
Thank you. Good morning, good afternoon, and good evening, everyone. My presentation focused on the Nile Basin experience on dam safety management. I'll go in detail first for the Eastern Nile part, and I will continue on the Nile Basin aspects. Next one. This is the outline for my presentation, just to give you a brief background of the Nile Basin and also for the Eastern Nile sub-basin. Those who do not about where the location of Nile Basin is. And next one is dam safety capacity building. What are the key activities and achievements made in the Eastern Nile during the last 10 years? And the third one is about the Nile Cooperation for Climate Resilient Project. That is a project which is include also dam safety as one project. And the fourth one is about my conclusion and recommendation. Next. The Nile Basin and Eastern Nile sub-basin. Next one. Yeah, this is just to give you an idea, an overview of the Nile River Basin, which encompasses about shared by 11 countries, Burundi, DR Congo, Egypt, Eritrea, Ethiopia, Kenya, Rwanda, South Sudan, Tanzania, and Uganda. So the river is shared by these 11 countries, except Eritrea. The others are members of the Nile Basin Initiative, which is based in Abebe, and also the longest river in the world, which is about 6,695 kilometers. And the basin encompasses about 3.2 million kilometers squared, with an estimated mean annual runoff at entrance to Aswan High Dam, about 84 to 89 billion cubic meters, according to the Nile Basin Initiative reports in 2021. And more than 270 million people live in this basin. And one of the challenges is also the climate variability or the climate change. So extreme climate variability, floods and droughts impacts the water source development and management. Even though the mean annual flow is 84 to 89, there is some variability in the annual flow because of this climate impacts. And the last one is just to give you the Nile Basin hosts more than 600 dams with a cumulative storage capacity of more than 250 billion cubic meters. It is almost 1/4 of the storage capacity in the African countries. Next. After I have mentioned about the Nile Basin, I'm going to in detail about the Eastern Nile sub-basin, in which I am focused on the dam safety activities. The Eastern Nile sub-basin encompasses 4 countries: Egypt, Ethiopia, South Sudan, and Sudan. And the main tributaries of this sub-basin is the Abebe Blue Nile, the Bara, Kubo, Sobat, Takazi, Atbara, Sitit, which the 3 of them are originated from the Ethiopian highlands. and also the main Nile that extends from Khartoum to Aswan to Mediterranean Sea. Next one. Now I am trying to give you some idea about the storage or the dams available in the Eastern Nile countries, which gives you an idea why a dam safety is an issue in the sub-basin. The first one is just to give you the GERD, the Grand Ethiopian Renaissance Dam, which is about 145-meter high RCC dam with an installed capacity of about 5,150 megawatt. It had also a saddle dam with 50-meter high concrete-based backfill dams. The dam is currently under construction, and the storage capacity is estimated to be about 74 billion cubic meter. And the Kaze Dam is also available in Ethiopia. It's the highest concrete arch dam in Africa. That is about 300 megawatt capacity. It was commissioned in 2009. Both dams are located in Ethiopia. Next one. This one is the Sennar Dam. It's located in Sudan. 39.5 high composite dams with masonry gravity and artificial flanks. It was commissioned in 1926. It has serviced more than 95 years. And it is located on the main river, that is on the Abebe rivers. Next one. The Aswan High Dam, I think most of you know about the Aswan High Dam, which is located in Egypt with 111 high composite dams, rock filled with concrete gravity dams. Second largest water storage capacity dams in Africa, which is a capacity of about 162 billion cubic meter. And also it was commissioned in 1970. This is just to give you some highlight about the large or mega dams available in the Eastern Nile countries. Next one. So the dam safety activity with regard to the Eastern Nile part. What are the key activities undertaken and what are the key achievements that we have made in the last 10 years? Next one. So the objective of this program is about assessing the dam safety practice in the sub-basin countries and develop a roadmap for subsequent actions, creating enabling environment with appropriate regulatory framework and institutional development to identify responsible entities, organization units, and also strengthen regional cooperation on safety management of transboundary dams. Overall, the main objective of this dam safety initiative was to see what is the capacity in the basin and what is the capacity gaps in the basin, and to do some actions on the gaps identified during the assessment. Next one. Yeah. So the project was launched in 2013 with the support of the World Bank as part of the Nile Basin Trust Fund. So it is almost 10 years since it started the dam safety capacity building programs in the Eastern Nile Basin. Next one. So what we did first was we have tried to assess the existing legal and institutional framework, technical and human capacity. What are the existing capacity of the basin in the 4 countries, in Egypt, Ethiopia, Sudan, and South Sudan? What is the legal or regulatory frameworks? Also, what is the institutional arrangement? Who is responsible? How it is arranged with responsible entity? What is the role of the regulators and also dam owners and operators? And also, third one is on the human resource capacity. Do the regulators, dam owners, and dam operators have the required technical capacity to manage dams in the basins? And also, the fourth one is technical capacity I have already mentioned about. Do they have standards, codes of practice, guidelines, procedures, and also other engineering tools? So what we have planned is to assess the capacity of each country in terms of these 4 parameters. Next one. So after we did this assessment, we have identified key capacity gaps in the countries in terms of managing these dams. The first one is lack of understanding of the risks associated with dam development and management. Overall, there is a perception that dams, once it is built, it will serve for 100 or 200 years. So we understand that there is lack of understanding on the risks associated with dam development. And second one is lack of legal and regulatory framework and responsible entities. The second one is we identified that there was no such responsible entity at national level to oversee the dam safety activity in terms of managing even at dam owners or at national levels. The third one is inadequate competence to undertake proper dam safety monitoring and safety assessment. This is at all levels, we identified capacity gaps or competence to undertake proper dam safety monitoring at dam owners level, at regulators levels, and also even at professional levels. The fourth one is expansion of urbanization and settlement of downstream of dams. As I mentioned earlier, there are dams constructed 50 years before. So now there are a lot of settlements in downstream of these dams, which is very critical in terms of safety aspects. Next one. Number of aged dams do not meet the current state of standards and practices. There are a number of aged dams along the main Blue Nile or Takaze and also on the main Niles, which have served more than 50 years. As I mentioned, for instance, Senar Dam has served 92 years, which was designed in 1920 or something like that. So next one is lack of cooperation in transboundary dam safety management. These dams have also transboundary effects, so there is no cooperation among the countries in managing the safety of these dams. Next one is financial constraints to undertake proper maintenance and regular safety assessment of dams. You know that proper maintenance work is one of the key aspects in terms of safety management, but we have identified that there is constraints, particularly by the dam owners, to undertake proper maintenance and regular safety assessment of dams. And finally, we have identified uncertainty of climate change and its implication on operations and safety of dams, particularly aged dams. So this is also one of the critical issues in the dam safety management in the Eastern Nile countries. Next one. So after we have identified the critical issues in these countries, what we did is we developed a roadmap. What are the actions to be undertaken to alleviate these problems or to reduce or to make some progress on the dam safety management in the Eastern Nile countries? So we prioritize the areas of, for instance, first one is creating awareness on risks associated with dams during construction, operation, and maintenance phases. So we organized creating awareness workshop and training workshop to policymakers and also dam owners, regulators, and also technical experts about the risks associated with dams. And second one is establishing dam safety units at national and regional levels. As I mentioned earlier, there was no any responsible entity at national levels in the countries to manage safety of dams. So we have to establish at least until formal regulatory framework is developed, a dam safety units to oversee the dam safety activity at national level. The third one is conducting training programs for dam owners and operators, technical experts, academia, journalists, and civil society on key concepts of dam safeties and principles. We have to organize a technical training programs for different stakeholders. And also developing reference dam safety guidelines. We have identified that there is a critical capacity gaps in terms of guiding documents or procedures to design or to assess the safety of dams. So we suggested to develop reference dam safety guidelines, which could be adapted by countries. And the last one is developing reference regulatory framework. As I mentioned earlier, this is the key concepts or the foundations to have proper safety assessment of dams or ensuring the safety of dams. So we suggested to develop a reference regulatory framework for the Eastern Nile countries. Next one. So based on that roadmap, we have organized different technical trainings. So more than 400 professionals have been trained in various dam safety related topics. So on these training programs, there are participants from parliamentarians, regulators, dam owners, dam operators, consultants, experts, and professionals. So a lot of stakeholders were involved in the training programs. In addition to the Eastern Nile countries, we have also invited experts outside of the Eastern Nile countries to take part in the dam safety training. Mozambique, Zimbabwe, Zambia, Malawi, Nigeria, Ghana, Liberia, Tanzania, Rwanda, Uganda, Kenya. We invited technical experts from these countries to take part in the dam safety capacity building or in the dam safety training programs. Next one. So this is just to give you one of the training program was to provide awareness of dam safety projects or dam safety relevance to high-level officials. This is in this picture you can see parliamentarians represented from Ethiopia, South Sudan, and Sudan. They attended the workshop. So we discussed about what is the role of government, dam owners, and operators in managing the safety of dams. There was discussions with the parliamentarian, their roles in terms of ensuring the safety of dams. Next one. And in addition to the awareness creation workshop, we organized technical training programs for professionals. This training provided comprehensive knowledge of dam safety concepts, principles, best practices with practical inspection and evaluation techniques for dams. So the training programs, the first one was held in Ethiopia, that was in 2013 in Koka Dam, Ethiopia. You can see on the left side the participants who are visiting the Koka Dam. So at that time we provided a dam safety assessment. One of the techniques of dam safety assessment, that is PFMA, potential failure mode analysis techniques to the 4 countries. So you can see on the right side of the pictures that the upper one is participants or experts from Sudan have done their own parts in Sudan, and the lower part is the experts from Ethiopia who did their assessment on the Takase dams. So we provided them practical training to do some safety assessment of them. Then they back to their own countries and did the same exercise in their own country. Next one. This is also part of the training. The left one is about the dam safety inspection monitoring in Senar dams, that is in Sudan. This is just to give them, the dam operators, how to inspect or how to conduct visual inspection of dams in their own country. And in the right side, this is about training on instrumentation and surveillance. This is classroom lectures. After they trained in the classrooms, they travel to the dam site and see practically how the instruments are measured and interpreted. Next one. This is just to give you an idea about collaborating with International Center for Hydropower that is based in Norway. We have collaborated with ICH, organized a dam safety training programs. So in these training programs, we invited experts from Nile Basin countries, that's as I mentioned earlier, from Mozambique, Zimbabwe, Zambia, Malawi, Nigeria, Ghana, and Liberia. So you can see that the Eastern Nile has done a lot of capacity building programs, not only for the Eastern Nile, but also for the whole Nile Basin, for the African countries, particularly the southern parts of Southern Africa. Next one. So internship programs, Intro or the Eastern Nile Technical Regional Office has internship programs. That is, creating objective is to creating a network of young water source professionals in the sub-basin and engage them in the development and enhancement of knowledge-based products. They are graduated, master's or PhD students, postdoctoral researchers from academic institutions, as well as young staff in ministries, and a total of 15 young professionals engaged in the dam safety programs. This is just, we invited young professionals from the 4 countries who are working in the ministry or in the university. They come to stay in Intro for 3 months. They have some training on specific topics. It could be in dam safety, it could be in water resource modeling, it could be in watershed management, it could be in water quality. So they stayed in 3 months. They do some training programs there, and also they do develop some deliverables that will enhance knowledge base of Intro. So with respect to the dam safety, we had 15 young professionals from the 4 countries. So in 5 batches. Next one. This is the product of the internship programs, the young professionals who developed Eastern Nile dam safety cards. They developed dam safety toolkits and also developed some deliverables after they stayed 3 months in intro. They developed some deliverables or products that would enhance the knowledge base of intro Eastern Nile dam safety card. The first one is the dam safety toolkits, and also the second one is about the preliminary seismic hazard assessment for the Eastern Nile. And the other 3 deliverables are in terms of design, construction, operation, and safety assessment of small dams in Ethiopia, in Sudan, and also hydrologic design guidelines for small dams. So all these products have been developed by young professionals in intro. Next one. This is just to give you a picture of them, some of the attendants, some of the internship programs. They attended classroom lectures or training, and they attend also field work or field training programs to inspect dams, and then they back to their home country and do some assessment of their dam safeties. So these are some of the internship programs participants. Next one. So as I mentioned earlier, Eastern Nile countries have difficulties to have some guidelines or standards or procedures in terms of safety management. So we developed 3 guidelines. The first one is reference dam safety guidelines for Eastern Nile, which encompasses key concepts and principles of dam safety management. And second one is dam safety training module, that is for the university, so for the academia, provide some dam safety training courses for their students, and which is collaborated or which is developed in collaboration with universities. And the third one is a small dam safety guidelines, specifically to address issues related to small dams management in the Eastern Nile countries. So the first one is reference dam safety guideline, is, as it is mentioned, the reference or a model. So countries could adapt this guideline to their own countries. Next one. So in addition to the guidelines, we established dam safety units at the national level. 3 countries, Sudan, Ethiopia, and South Sudan, have established a dam safety unit, which is responsible to oversee dam safety activities at national levels. And also we developed a regional reference dam safety regulatory framework. It is developed, but it is still in draft level. Next one. The next one is about the Nile Cooperation for Climate Resilience Project, which is called NCCR. It encompasses the whole Nile Basin countries. Originally or previously, it was only for the Eastern Nile, now come to the whole Nile Basin countries. The program started in 2021 until 2025. It was supported by World Bank, CUA Fund. Next one. So just to give some background on this project, it was launched in 2021, will be completed in 2025. It builds on good practices achieved in the Eastern Nile Dam Safety Project. It was observed that there is a good progress on dam safety management activities in the Eastern Nile countries. So countries would like to upgrade or scale up the projects to the whole Nile Basin countries. That's why these projects came to picture. It encompasses all Nile Basin countries, coordinated by the 2 NDBI centers, Eastern Nile Technical Regional Office at Intro, that is in Addis Ababa, and also Nile Equatorial Lake Safety Reduction Programs, coordination units, near SAPSU, based in Kigali. The overarching objective or the key objective of this program is strengthening the institutional environment for dam safety, improving the information base, and increase coordination of dam safety management in the Nile Basin countries. Next one. So the component of this project is conducting training programs on various dam safety related topics, establishing national dam safety units in the Nile region, as I discussed earlier. Eastern Nile countries have established their own dam safety units. Now the next step is to establish these dam safety units in the Nile regions. Strengthen national dam safety units at basin levels, and also develop a geo-referenced inventory of dams in the Nile Basin, just to have the idea of the number of dams with geo-referenced data in the Nile Basin countries, to have some information on the available dams or existing dams in the Nile Basin countries. Next one is development of a type risk management framework for dams in the Nile Basin. And next one is an assessment of the legal and institutional framework for the dam safety in the Nile Basins. And also just to see what is the legal and institutional aspects in the other parts of the Nile Basin countries. As I mentioned earlier, we have tried to see some assessment in the Eastern Nile, but now to make it more comprehensive, it was suggested to develop some assessment for the whole Nile Basin countries. And next one is development of a model national regulatory framework that covers standards for new dam development and safety of existing dams. So it is a very critical thing that we have a regulatory framework, as I mentioned earlier. So we are going to develop, or one of the ideas of the project is to develop a model national regulatory framework. So countries could adopt that framework for their own purposes. And the last one is establishment of a regional dam safety training center. Considering the number of existing dams and planned dams in the basin, it is a need to establish a dam safety training center. So one of the assessments would be to undertake the establishment of this regional dam safety training center in terms of national arrangement, also the location or hosting countries. Next one. So key accomplishments, as I mentioned, it was started in 2021 until now. Training of experts on various dam safety related topics have been carried out. And also draft report on Nile Basin dam safety regulatory framework assessment was submitted, and consultation meeting with Nile Basin dam safety working group was conducted. As I mentioned already, the draft report was submitted and discussed with the key stakeholders. And third one is draft report on inventory of dams in the Nile Basin was submitted, and consultation meeting was Nile Basin dam safety working group was conducted. So the inventory of dams and also the framework are now at draft level. A consultation was made, so hopefully they will be finalized in the coming 1 or 2 months. Next one. This is my conclusions. Building of institutional capacity is of paramount importance for sustaining and ensuring safety of dams. I think you can understand, recognize the need to have capacity building programs at all levels. And next one is setting institutional dam safety management. It means including the legal, regulatory framework, responsible entity with required technical capacity and financial resources in place. We have to ensure that dams are properly designed, constructed, operated, and maintained safely, and do not pose an acceptable risk to the structure's life, property, and the environment to downstream communities. So this is my key message to participants, particularly for developing countries. You have to formulate a standard dam safety or national dam safety management at a national level that will contribute to ensure the safety of national dams or transboundary dams. Next one. Thank you very much. Finished.
Thank you, Mika. It is really lovely to see all the work that you and your team have done. We'd really like to thank you for that, because as most of us know, in many African countries, we do not really have standards and guidelines on how to actually safely look after and monitor our dams. Thank you for identifying the problems that we are experiencing with our dams and how we can approach them with the roadmaps and guidelines that you and your team have written up for us. Next, we have Mr. Louis Hattingh from Hattingh Anderson Associates, who will be presenting his presentation on practical monitoring considerations.
Good afternoon, everybody. I've seen quite a few well-known names in the meeting chat. So some of you have met me, but yeah, I'm going to talk to you guys today about some practical monitoring considerations. I want to first start off with actually with acknowledgements, and I know one normally do acknowledgements at the end, but I might actually run out of time. So before I actually start giving this webinar, I want to just share with you guys that I had a wonderful group of people that mentored me through the years. Yes, I'm maybe some of you guys have seen me. I'm also grey nowadays, but there's one particular person that was a lot of what I'm going to tell you today. I learned from him, and that is Dr. Chris Oosthuizen. There's many people that would actually know him, that may most probably listen in today, but he, I think, made a huge difference to a lot of people, especially on monitoring and surveillance. So I want to first tell you guys what I'm not going to do today. All right. So I'm not going to provide you any recipes or specifications, and I'm not going to tell you how many instruments you must use and where you should actually use them. What I will do is share some of my experience, and hopefully I'll pose some questions, and I will provide some food for thought for you guys if you want to actually do something on the monitoring side. And I'm going to really focus on the basics. So I'm not going to discuss any new technologies or sort of new things. I'm really going today to focus on the basics that normally don't get a lot of attention. So I want to start off with and pose the question, what is the definition of surveillance? Because I see this, and I'm by posing this question, I'm actually putting my ICOLD committee on dam surveillance hat on, because I know the industry out there intermittently actually talk about surveillance and monitoring and inspections and sort of mix all these things together. So in the ICOLD sort of sense, in the bulletins that that was produced in the past, the definition for surveillance actually includes three major aspects. The first is monitoring, then visual inspection, then checking and testing. Okay. And checking and testing is not checking and testing the results of your monitoring and visual inspections. Very important. Checking and testing are for those components like your mechanical equipment, your electrical equipment, all those sort of things that we struggle to either do visual inspections and monitoring, that we need to on a regular basis do checking and testing. All of that together, we actually use the definition of surveillance. Okay, so in my rest of my talk, if I talk about surveillance, that's what I mean. Monitoring is actually using instruments to get information about certain aspects of your dam. Okay. So why do we do surveillance? And as a young engineer that came out of university, I actually don't understand this concept that I want to share with you guys. So it's very important to actually consider the need for considering risk. As engineers, we actually make extremely complicated decisions normally with not a lot of information, or not all the information that we should actually need. Okay, and that's normally because of time constraints or financial constraints, and that basically leads to uncertainty. And that as engineers, we get taught to actually try and manage this uncertainty, but a lot of people actually don't appreciate it. Either managers of infrastructure or designers. Many of them actually don't give consideration how important it is to actually manage this uncertainty. And so a big part of the job of these people is actually to manage the risk of this uncertainty. The other concept that I want to talk to you guys, and I'm talking to you guys about these concepts because it's very important to understand it with regards to monitoring as well. If we have uncertainty about something, one of the ways how we can actually manage it or improve it is to actually gain more knowledge. The more knowledge you actually have about your subject that you have uncertainty about, the less uncertainty you actually will have. Okay, so this is one of our really good colleagues in ICOLD, Bernard Gogil, quite a few years ago came up with this concept of knowledge management during the whole lifespan of the dam. Okay, so when you start off in the beginning, when you start planning a dam, you normally have basically no knowledge, and as you go along through the different processes, we actually gain knowledge, and it's very important that we actually manage this knowledge well as well. And one of the things that how we can gain knowledge during the operational phase of our dams is actually to do proper surveillance. So to do proper monitoring, to do proper inspections, and to do proper checking and testing. But it's also very important to properly manage that knowledge. If we don't manage it well, then we get to the situation that is indicated here in green. We actually lose knowledge. Okay, so you guys will see this this schematic that we talk about knowledge management actually shows a time scale of 30 years. So that's one of the other questions that you have to ask yourself. What is the lifespan of a dam? Now I know if you ask a designer that, they will tell you what's the design lifespan of a dam. Mikkel just earlier talked about older dams like Sennar Dam that's now nearly 100 years old. That is way past its design lifespan. Typically, designers design a dam for a 50-year design lifespan. So I can tell you with certainty that most dams will actually become older than the design lifespan. And that is very important to remember, especially when you do design. So a typical example of this is, for instance, I had the opportunity to visit the two Roman dams, Proserpina and Canalvo dams in Spain. They're close to 2,000 years old, and they're actually still functional today. Yes, through the years, there's been rehabilitation, well, decades and centuries, they've done rehabilitation to certain parts like the outlet systems and things like that, but the civil structure is still as it is pretty much how the Romans built it nearly 2,000 years ago. So if we actually now go and look at this, the concept of knowledge and how we gain knowledge and how we manage knowledge, we, instead of actually looking at 30 years, for those dams, we could actually add 200 years. So with this in mind, it's actually very important to appreciate that this knowledge management is actually an intergenerational aspect that one really need to consider. I mean, so one of the questions is, yes, you are now operating the dam, but there might be 2 or 3 or 4 generations after you that actually need to know about the behavior of the dam when you were operating the dam. Okay. So I was talking about the risk management or the need to actually consider to manage this uncertainty that I was talking about. And so surveillance plays a very crucial role during the operational phase of a dam to actually manage the risk of this uncertainty, because we gain information and we can actually take preventative actions if we see that we might actually get a failure before the failure actually happens. So one of the other things that I grew up in my system, and I can promise you guys, it is crucial to really appreciate this, is there, as Ralph Peck have actually stated as well as you can have, is there is no substitute for systematic and intelligent surveillance. It's very important. Systematic, intelligent. Okay. If you don't follow those two principles, I can, in many cases, as I get older, I actually tell people that they're wasting their own time and they're wasting other people's time, because we're actually creating more uncertainty if we don't follow those two principles. Okay. Very important to remember that. Now, with that in mind is, if you want to do, Mikhail was talking also about dam safety management, including surveillance, you need to understand how your dams are actually going to fail. Okay, what's the failure modes and the failure mechanisms? And for you to be able to understand your failure modes and your failure mechanisms, you need to understand the dam materials that you're actually working with. And in many cases, people don't understand the dam materials that they're working with, especially if they talk about surveillance and especially monitoring, and they implement the wrong solutions. Okay, and then you actually create more uncertainty because you don't get what you want to actually get out of the effort. The other very, very important concept that I want to sort of highlight to you guys, and that, again, I grew up in a system that really believes in this, and unfortunately, John Dunnicliffe, that actually wrote this, and in his book, that is one of the sort of, you can say, guidance books that we use in monitoring, is that every instrument on a project should have selected and a place to assist with answering a specific question. If there's no question, there should be no instrumentation. So you need to understand why you actually put the instrument in. Why do you do monitoring? I see it so many times that people, when I ask them, why did you put the instrument in here? They will tell you, well, I saw somebody else put it into their dam, and I thought, well, if somebody else use it, we can just as well use it. It will create more uncertainty. Okay, so you need to understand what your system is actually, or what your dam is doing. So the ideal monitoring system is as follows. It should be simple. It should give you sufficient information when you need it, okay? And with that, we always use this word redundancy, and I will talk a bit about redundancy later. About it should be durable, reliable, low cost, low maintenance, easy to measure, and provide you with foolproof readings. That sounds all so easy, but I can promise you it's not so easy. So I'll try and give you some guidance on that. So let's just give you a bit of a summary for what I've just actually been trying to tell you guys. So monitoring, I believe, is instrumental in, or surveillance, including monitoring, is instrumental in managing uncertainty. But you need to understand your uncertainty. You also need to understand your potential failure modes and your properties of your materials, and you need to be systematic and intelligent. Okay, so that is absolutely important. Okay, when you want to do proper monitoring. So the next thing that I want to talk to you guys is about some terminology that we use, and I'm actually just going to focus on the first one, the term metrology. And in some dictionaries, if you actually go and look at the definition of metrology, it actually says the art of taking measurements. Now, I can't agree more than that. It's really an art to take proper measurements. And what I've seen through my professional life, unfortunately, the majority of people that is actually required to make or to take measurements are not trained to do proper monitoring and to take proper measurements. Unfortunately, it is not the focus of most people. So hopefully after today, I can inspire a few people to actually take those people and get them trained properly so that they can take actually proper measurements. So how do we do basic metrology? Okay. The first thing is calibration requirements. Okay. So if you want to take any proper measurement, you need to do calibration of your readout unit. Okay, very, very important. If you take manual measurements, every time you do a measurement, you should actually do calibration. Some of you might say, Louis, that will take too much effort. I can promise you that's where you actually create uncertainty. If you don't take calibration measurements, you will end up with measurements that you can't trust. Okay, automatic, very important that you actually calibrate the whole system from time to time, but also have a system where you can perform regular manual readings. Okay, you need to actually follow uniform procedures, and I will try and show you later on why I say it's so important to actually follow uniform procedure. So always do it the same time, every time, the same time of the day. Okay, and have an operating procedure and train the people that must take these measurements that they actually do that. Then the other thing is you need to validate your measurements immediately afterwards. In my world, I basically work in Africa. I see it so many times. People take measurements and then either they do no validation or they will only do validation weeks or months afterwards. That's too late, people. It's way too late. You need to do it the same day that you actually take the measurement. You need to do the validation. Otherwise, if there's something that you have not validated, okay, you will lose actually that measurement. All right. And also take care when you're doing these readings. Okay. So there's some other general monitoring things that really is very important to follow. One of the things that I want to highlight here is to have proper signage of the instruments at the dam. Okay. So you guys can read most of that, but that's what I want to highlight out of that slide. So one other thing that is very important, and I struggle to convince a lot of people about this, it's also very important to collect monitoring metadata. Whether you do manual monitoring or whether you do automatic monitoring, extremely important. So the databases that you guys actually have, whether it's Excel and whether it's a customized information management system, should make provision that you can actually record the metadata. And those metadata includes, for instance, if it's a manual recording, who is the person that was responsible for the observation? Information about what's the readout unit you use, or even data logger that was used, your calibration readings, and any comments that actually came out of that. I've seen it so many times. You try and do interpretation of monitoring results, you see a step, you don't know 20, 30, 40, 50 years down the line why the step happened. If you are fortunate enough to actually still talk to somebody that was involved, that was at the dam, then normally they will tell you, well, we started using a new readout unit or the instrument was replaced. But it's extremely important to actually record all those metadata for your monitoring system. Okay, so I'm going to just quickly show you guys, for me, a very good example here in Africa of a dam where very good monitoring is actually taking place. So this is Korabasa Dam in Mozambique on the Zambezi. It's one of our mega dams in Africa. It's a 170-meter high concrete arch dam. And they have more than 1,000 monitoring points in the dam, and every single monitoring point is actually, you guys can actually see there, have a description there. So it's an instrument name, the elevation of the instrument, and they even actually put the database number there. So every single instrument that you get to, you don't guess what instrument you're actually working with. And these guys have been trained since the beginning of the dam to actually do things properly. So here, you guys, I'm going to show you some examples. Every single instrument are actually have proper signage. This is an old Carlson. It's before the vibrating wire instrumentation became the norm. So those are the instruments installed in the early 1970s, and you guys can see what they actually do. Every time that they do a measurement, they clean it, and then they take the measurement, and then they will clean it again, and they will protect it. So you will see no corrosion. Okay, so those are actually brass, but you see no corrosion. There's even a setup at each of these stations that you know precisely what you're actually dealing with. There's still the old readout unit that they still use. That was a couple of years ago. I haven't been at the dam for a while now. But you guys can see this is some of the things that they carry with them. So they actually carry with them things that they can properly protect and clean the instrumentation. And I don't see that a lot in other dams. Okay, very, very important. So this, yeah, you guys can actually see just some more photos. And as a result, you actually get data sets of information. Here you guys can see that the displacements, for instance, with no gaps. So if I look at that, and with the concept of uncertainty, if I look at that information, it actually does not create uncertainty in my mind. It actually creates certainty about what I'm actually trying to measure. The interesting thing here to remember is that Mozambique was actually in civil war from 1977 to 1992. So it's amazing for me to actually see a dam where, with a record like this, even when we had the civil war going on, okay, in the country. So now I'm going to show you guys some examples of where things, you guys can see this is a big dam here in South Africa. And then since 2004, the information started getting a bit iffy. And you will agree with me, the uncertainty of what actually, with regards to the displacement at this dam actually happened, increases. Okay. Here's another example of a dam. Okay. That basically you guys can see fairly good information until about 2001, and then it seems the person who's supposed to actually do the monitoring just completely lost interest. So since 2001, we basically have uncertainty about the behavior of this dam, okay, which increases the risk for us, okay. So that is what we don't want to do. So this is, I want to pose some questions to those of you who are actually performing dam safety evaluations, all right, today. And so the first one is, have you checked whether the dam operator knows how to actually do proper metrology when you did your inspection for your dam safety evaluation? And if you found out that the person actually doesn't know, that you show the person how to do it properly, or you must actually ask yourself, do you yourself know how to do proper metrology? Okay. The other thing is that normally it doesn't happen. People do dam safety evaluations, do inspections, and they don't do an evaluation and an inspection of the monitoring system. It is crucial that you actually do that. I get it many times. People ask me to help them with the interpretation of monitoring information. They just want to send me the information. They don't want me to actually go and visit the dam and see do actually evaluation of the monitoring system, it is absolutely crucial to go and do an evaluation of the actual monitoring system. You can't just do desktop interpretation. Okay, that's what I've learned through the years. You're going to miss things if you just try and do desktop evaluations. Then also about calibration. It's crucial that you actually check out if the calibration is done. Then also, does the dam owner have a proper program and procedures? For instance, if I can refer you back to what the guys at Korabasa does. So they have a fixed monitoring program that is fixed every single day. On the program tells them what they should be doing. So in the morning they go out, they take measurements. In the afternoon they come back, they validate the measurements, and they do maintenance and repairs to their equipment. Okay. The other thing also, your operation and maintenance manual should contain all this information about your monitoring system. I see it so many times. Your O&M manual don't contain anything about surveillance, not about monitoring, not about inspections, not about testing and checking. Absolutely essential. Okay. So my last half an hour of this webinar, I'm going to focus on some basic monitoring questions. Okay. And this is really applicable to both manual and automatic systems. All right. I'm also going to just touch on proper presentation, and I want to talk about safety, especially safety when we do monitoring and we do manual monitoring. But even when you actually, when you have automatic systems, you will still have to go out there. So I will talk about that. So I'm going to start off with crack gauges, which is one of the simplest of instruments that you can actually install in a concrete dam. Okay, so crack gauge just measures displacement, okay, or translations. But if we actually deal with concrete, it is very important to understand the characteristics of concrete. Okay. And many people don't take that into account when they actually decide on a specific monitoring system. So one of the things are, for instance, your elastic properties. So concrete is a relatively stiff material. So even for large loads imposed on concrete, it actually does not displace a lot. So that is one of the things that you actually need to take into account. But then we have things like creep, sinkage, permeability, and very important, if we deal with dams, these chemical reactions that cause swelling. Okay, I'm not going to use alkali aggregate reaction or alkali silica. I'm going to refer just to chemical reactions that causes swelling. Okay, doesn't matter what the type, but it's very important to actually keep that in mind. All right. So as I said, and I want to highlight it again, you need to have an understanding of the expected behavior of your structure before you decide on your monitoring solutions. And with the crack gauges as an example, I'll try and actually show you what I'm meaning with this. All right. So there's some questions that I'm going to try and answer. So about accuracy, the instrument type, the frequency of measurements, the readout unit, and calibration. Okay. Those are typically some of these questions you can actually ask for most monitoring systems. All right. So I'm going to show you some examples which I've seen through the years that people implement and they pat themselves on the shoulder and I think it's a good solution. So this is an example where they've just measured with a ruler in between, and I think that gives you a good answer. Then one of the things, and I see still a lot of people that actually think using these telltale crack meters is wonderful. Okay, my first question to you would be, what is the accuracy of an instrument like this? And I can tell you it's more a millimeter or more. Okay, so I'll try and show to you now why I think this is not appropriate. It does not really give you any appropriate answers, and you can see a lot more if you install appropriate instruments. That's what I'm trying to actually tell you here. So the other thing is, now we're getting into the more, these are 3D, the normal 3D crack gauges, and a lot of people in my world actually use these calipers, either old manual or digital ones, and I think that is appropriate. The accuracy from your readout unit that we get is appropriate. I will try and sell you that you actually will struggle to get appropriate answers if you use a caliper. Okay, so what I would suggest, I'm not trying to sell, but is to actually use a digital micrometer, okay, that fits, that has been adopted to actually fit snugly in your 3D crack gauge. All right, and these are the 3D tilt crack gauges. All right, that we nowadays use. So you can actually get rotations as well as translations from the results of these. So the other thing that I see a lot is if we use like these crack gauges, in general, people think that using a frequency of 3 monthly readings is good enough. And yeah, and I know a lot of people in the dam industry actually think these crack gauges don't show you anything. And I must agree with you if I see a graph like that or a presentation like that, where the operator actually tried to do 3 monthly readings. I do agree with you that that does not show you a lot. And I think most of you guys will agree with me that it doesn't show us a lot. But now if I show you something, I want to show you the next one, where we have a very good operator that takes 2 weekly readings, that is systematic about it. So first thing in the morning does the readings. Then you guys will actually agree with me that the readings that I'm showing you, the results that I'm showing you here from the same crack gauge, the same type of crack gauge, we can actually see a lot more. So here, if I can just show you, you can actually see the seasonal temperature change loading that we see. We actually see permanent deformations here. And I want to highlight basically the scale here. So this is 1 millimeter. So now you guys can actually start thinking, if you have something with an accuracy of 1 millimeter, then we might just see some of the tangential measurements, but we won't even have a good idea about it, okay? And we will not see any of this radial and vertical displacements. That is crucial, the permanent displacements as well as the loading that we get from seasonal temperature changes. Okay, so for instruments like this, I think looking at this, you will agree with me, we need an instrument with a 0.1 of a millimeter accuracy, otherwise we will not see what we actually want to see from the results. Okay. And we also need to have a systematic approach when we take the readings. I will try and show you why it's so important to be very systematic, to always take the same instruments reading at the same time of the day. Okay. So I want to show you, this is, I know this is actually displacement angles, but it actually shows you. So this is a automatic monitoring results on top of a gravity structure, but it basically shows us the same, it would show us the same as the crack gauges. Now this is over a year. You guys can see the red is actually the temperature. So this dam's temperature in the instrument goes from less than 10 degrees to well over 40 degrees. So we have an extreme spread here, and the X and the Y directions show here. But I want to actually zoom into a week to actually show you guys. So if we actually go and we just look at the results of the week, we can actually see the daily temperature flux. All right, this was in January, which is our summer here in South Africa. And you guys can actually, this displacement angle is pretty similar to the displacement that we actually see. All right, it's directly related. So you guys will see during one day, we actually see nearly 2.2 millimeters of displacement. So if we actually would do a measurement one time in the afternoon and the next time in the morning, we might actually get a 0.2 millimeter difference. And a lot of people don't understand actually, if they work with concrete, the impact of daily temperature loading and changes to your structure as well, especially if your instrument is actually installed on the surface of your structure. Okay, so very important to be systematic, okay, when you do monitoring. All right, so the other thing, just if you do it properly, crack gauges can show you and tell you so much when you do proper interpretation. It can show, I was telling you about permanent displacements that from swelling reactions, you can get a very good idea. For instance, if you work with an arch where your main arch action is, where your main stresses are concentrated, all sort of very, very important information actually from this very, very simple instrument. Okay, and I know a lot of people will, especially in the concrete dams feels it's a waste of time to actually use this instrument. So this is basically just my take. As I said, definitely use a 3D crack tilt gauge, definitely accuracy 0.1 millimeters. Make sure you have calibration that you actually do before and after your daily measurement. Okay. So just I want to, some other important concepts that I want to talk about is with regards to geodetic surveys, and I need to speed up a bit. I see I've fallen behind with my what I wanted to tell you guys. So if we look at some of the issues that I see, especially when we want to do geodetic surveys with concrete, is with regards to accuracy and also with regards to thermal effects on the instrumentation as well as the network. And also in many cases, I've seen people don't understand that you actually need to have a proper network on the outside. They think you can actually do just from one fixed point outside your dam a measurement. All right. So, and maybe this might not be relevant for many of you guys, but in the world that I work and live here in Africa, I see a lot of times people actually think that you can use a normal surveyor with a GPS system to perform a geodetic survey of a concrete dam. Okay. And then I even see these surveyors where they claim they have 1 millimeter accuracy. And if you actually go and look at the accuracy of these systems, you will know we're still looking at about 10 millimeters accuracy. Okay, so definitely, absolutely not. If you want, especially if you work with an important large dam, it will not provide you with the accuracy and the right answers if you actually use that. And what I mean with this is people actually just using normal survey studs, and they have a mobile prism system that they're trying to balance, and they're walking around here. And I think I've already showed you about typical displacements that we can actually expect in a concrete dam. So definitely that would not work. So you really need a high precision survey equipment to do that including high precision prisms, for instance. Okay, and a permanent setup. All right. The other thing that I've seen, that we've really seen through the years, and we've changed it here in South Africa, is, I know this example that I'm showing you guys, these are the beacons, either on the dam wall or of your network, but especially your network. If you have a beacon that is from concrete and that is not isolated from thermal effects, that will actually displace as the sun goes around and have a huge effect on the accuracy of your geodetic measurements. So you need to have a system where you can actually isolate your beacon, all right? This is a double system that we use, so that there's your beacon, and that is actually thermally isolated, all right? There's some examples of networks. That's Katsi Dam and Lesotho's network, all right? And then the other thing that is very important for me that I've seen through the years, I've seen in many cases people implement geodetic survey systems and they focus on the center cantilever. Okay, they might extend it to the crest of the dam wall, but they don't actually do a survey of the whole dam, if, for instance, an arch dam. So this example that I want to show you, especially when you deal with an arch dam that have swelling due to chemical reaction. This is Koga Dam in South Africa. So if you look at the center cantilever, okay, and you look at the swelling that is the vertical displacement, then in most cases, and I've seen it many times, people just look at the center cantilever and they look at the vertical results. For this, they would conclude that since 2003, well, the swelling in the dam has actually stopped. Okay. Unfortunately, that is incorrect. So if we look at actually the quarter points, all right, and we look at the displacement in the upstream direction, you guys will actually see that the swelling has continued. So very important to understand your structure and understand things like the actual the properties of your swelling. All right, good. Then on embankments, that's the only other thing on embankments that I want to highlight. I've seen this many times, the position of survey points. This is typically, this is a dam. It's got actually a public road over it, so it's basically impossible to have a beacon in the center of the dam. But people actually evaluate it and say, well, it's got a clay core. There is a clay core you guys can see, and I've seen the reports where people actually refer to the displacement that we get to, that's the core's displacement. What we're actually monitoring here is the rockfall shell displacement and not the core, clay core. So be very careful when you do interpretation, especially with embankment dams. Make sure if you say it's your core's displacement that you're looking at, that it is actually on the clay. Okay. So there is some basically takes for you that you can from my side. So yes, accuracy on concrete. I really my experience have taught me that we try and actually get as accurate a measurement for concrete embankment. We can use the GPS accuracy, so 5 to 10 millimeters. If anybody tells you that GPS can give you better, especially like the mobile ones, yeah, maybe in a couple of years' time we get that, but not at the moment. All right. So the next one that I quickly want to talk about is seepage measurement, and it just it's an important concept, it's a basic concept that I want to talk about to you guys on this. So here's some of the examples of typical seepage measurements, especially for seepage in dams. And well, in my environment, most people actually use these V-notch weirs. Okay, and through the years, I've actually have come to be reluctant actually to use the V-notch weirs, and I'm going to just show you some examples. But here's some of the seepage wear issues that I just want to highlight. So you guys can see there's a lot of things that can actually go wrong if you do seepage monitoring. But what I want to highlight also, if you do automated monitoring, is to make sure, and especially if you actually use piezometers, vibrating wire piezometers, is make sure that you actually use a vibrating wire piezometer that can be activated, especially in that water depth that you're working with. I've seen it so many times. People use normal vibrating wire piezometers where the diaphragm only gets actually activated when you have more than 1 meter or 2 meters of water pressure, and people are trying to use it in 100 millimeters or 200 millimeters. So you will actually get not the right answer. Okay, so be very careful. I'm not saying it's really good to actually use automated monitoring systems for that, but with that, I will talk a bit and show you guys, you need to be able to calibrate that regularly as well. Okay, so here's just some examples. So you guys can see this is a completely sedimented V-notch with very difficult to actually monitor. It's this particular solution that was implemented is actually got each time you remove the ruler. Okay, this particular case, the water is a supercritical flow upstream, so also very difficult to monitor, do proper monitoring. This example I want to show you guys, so it might look very good. If we go around the corner, you will see very difficult to actually take a physical reading. In this particular dam, they tried to implement all sort of automatic systems, and none of them was successful, to be honest. A lot of sediment in this one. So sediment, if you still do manual monitoring, and if you understand hydraulics, that will have a huge impact actually on what the results that you can actually calculate if your gauge, your V-notch is completely sedimented like this. This example, you guys can see, look at the amount of seepage around the V-notch plate, and also the ruler actually sits there that you must take a measurement. It's basically impossible to do a proper measurement with the setup. Okay, this as well, you guys can see, look at just all the seepage that actually goes around the plate. Then the other thing, if you do manual monitoring and your water level stays the same, you do get either corrosion or discoloration actually of your gauging plate. So it's actually recommended to use something like this. This particular photograph, I need to thank my colleague Manuel from Spain. Manuel, I used your photograph for this. I hope you don't mind. But this is an automatic setup, and you can actually, from time to time, you can go and do a manual calibration to still see that you actually, the results of your automatic system actually still gives you the results that you think it's actually giving you. So if you have an automatic system, you need to design it that you can still do in some other form manual readings to actually make sure that your system is still working. So what we found through the years, one of the things that you consider to actually use is, especially if you work in a dam that you have sump pumps, is actually put and you pump it out. put some meters on there and do volumetric monitoring of those pump volumes. It gives you, this is an example of Nato Dam in Namibia, and it gives you very good results, better results than what the V-notch would have actually given you. Okay. In this case of interest, so this is, you guys saw this very flat arch there, and this is in winter, our colder part, so that's actually just the arch bending forward, and the heel, the upstream side of the arch opening up, and actually you see the increase in seepage. We see that basically in most of our arch dams. You will actually see that if you do proper monitoring. The other thing is that as I get older, this is my preferred actually method of measuring seepage, and that is volumetric. I know I show you guys as a very basic, you will say, but Louis, it looks like a backyard job. It's just a pipe that's been put in there, and you have a calibrated a collection bucket at the bottom, and you just take the time. It is the most accurate that you can actually do. Of interest, I referred you guys to Korabasa. In the past, they've been doing volumetric seepage monitoring since the 1970s and very good results. Okay, so this is the example that I want to show you guys, and you guys can see the same. So in winter, you can actually see an increase in seepage that's expected. The only other thing I said, talking about presentation of results, if you want to compare seepages with each other, one of the techniques that you can use is actually, I don't know if you've noticed, a log scale on your seepage if you want to compare a very small seepage with a larger seepage. A log scale actually works really well if you want to do that. All right, so I'm not going to, I think I've already said what I wanted to say about seepage. Before I actually sort of finish with concrete dams, I want to pose a question to you guys about drainage holes. And it's unfortunately, I can't see your responses. But very few dams is there any monitoring done on drainage holes. Okay. And my question to you would be, why? Because for me, drainage holes is one of the most important aspects of a concrete structure, in that it actually drain your foundation or your concrete structure. And we assume that that drainage is actually working perfectly. We assume that we reduce the uplift, but we don't do any monitoring on the drainage holes. So where I've been actually involved, I have started to do drainage hole monitoring. So the first thing is, you need to regularly clean your drainage holes, okay? Because they do get clogged and they do stop functioning if you don't clean them regularly. And one of the things that you can actually do is very basic, monitor the depth, but you should also monitor the flows from your drainage holes and the water levels if there is no flows, because that will give you an indication what's actually going on in your foundation, all right? In most cases, that is the only thing that can tell you what's actually going in your foundation. And if you go and you know about failures of dams, especially concrete dams, then one of the most important potential failure modes is actually failure in the foundation, or on the interface between the concrete and the foundation. Okay. So very, very important to actually consider how you're going to do drainage hole monitoring going forward. Okay. Lastly, on the monitoring side, I want to talk about redundancy. Okay. So there's sort of different types of redundancy that we talk about. And the example that I'm going to show you, I thought actually highlights both types of redundancy. So we have pretty much, you have to consider when you embed instruments, whether it's in concrete and whether it's in soil, you need to actually think, and I'm going back to what I told you guys before about your lifespan of your dam, is do you have enough redundancy? I mean, once you've passed the stage that you've embedded your instrument and you want to start monitoring and suddenly you have no results and the instruments are not working, what are you going to do? Okay. The other type of redundancy, or if I say type of redundancy that we normally use, is using different monitoring methods to actually confirm results. And I didn't know how to actually explain it any other way. You only actually will realize the value if you have different types of instruments that basically give you the same answer, is if you have one type of monitoring system that really tells you there's an issue at the dam, but only one instrument, and you don't know whether you can trust the instrument or not. Okay, and that's a very difficult situation to be put in. Okay, so that's the other reason why you actually need to look at redundancy. So I'm going to talk, I'm going to try and use earth pressure shells to actually explain the concept of redundancy. So for me, if you use earth pressure shells, you want to actually go from total earth pressures to effective earth pressures, okay, to principal effective earth pressures, because that is what we really want to know, especially if we work in an embankment where we expect some arching to happen. In other words, some negative earth pressures that can cause piping, internal erosion in our structure. Okay, so unfortunately, most applications of earth pressure shells is actually such that we end up at best with effective pressures. The way there's not enough redundancy that we actually can get to principal effective pressures. And why do I say this? All right. So this, if we look at the plane, okay, this is a particular plane, and we look at these instruments, each of these actually would represent an instrument, okay? If we look at that, if we take number one, and we for instance use the Moore column theory, and we go to number two, and we go to number three, and we go to number four, you guys will agree with me, I actually have enough information to solve the unknowns to actually determine my principal stresses. Okay, so we need that amount of instruments to actually determine the maximum principal stress and the minimum principal stress. Okay, if we go to the typical situation, as I say, I see in most applications people install at most a vertical one and a horizontal one, and we will actually end up with that, and you guys will agree that with those two instruments we cannot solve, we cannot actually determine the maximum and minimum principal earth pressures. So that's one of the things that we talk about redundancy. You need to actually, you guys have seen we need 4. So the question with that is, if we only install 4 and one of them don't work, we will not be able to actually install, calculate our the principal stresses. So this is an example here in South Africa of a dam where we did a cluster installation. Here you guys can see total earth pressures. So that's without looking at the piezometric pressures at that situation. And if you look at it, it actually might look to most of you guys, we have total earth pressures. It looks fine. If we actually go and do the calculation and we convert that to principal earth stresses, we do go through that process, okay, you guys will actually see that we have negative earth pressures. The principal earth pressures that we calculate is actually negative, and we can get an angle for that as well. All right. So this is typically a cluster setup that we've used in the past here in South Africa. You guys will see even on the piezometer side, we need the piezometers to determine effective earth pressures to make sure that we have redundancy in there. We installed 2 piezometers, and what we actually have here is basically giving us redundancy. All right, in both directions that we wanted to actually determine the principal earth stresses. And there's just a example of the installation. All right, so there's some typical instrumentation. I'm not going to talk about it. I'm actually running out of time. Just quickly on proper presentation, for me that's very important. So proper interpretation of your monitoring results. That helps you already. If you do proper presentation, yes, you need to go and analyze it, maybe with some regression and so forth as well. But as a first step, it helps you considerably to do proper presentation. So this is an example of a vertical extensometer. This is a more than 100-meter high embankment, clay core with rock shoulders. Okay, and this is typically how it was presented in the past. The results were just put into Excel, and it was left over to Excel to determine the coloring and whatever. One has even difficulty to see which years it is, but this is a standard Excel presentation. So for me, if we actually go, so what I normally like to do, I like to use different colors. So in this color, the top part was I used the browns and the reds. The middle part I used the greens, and the bottom part I used the purples. And if you actually use a system like that, you guys can actually immediately see what's going on. So these are the total settlements. These are the settlement between each measuring point. And if you actually use that, it's very clear that here in the center of the dam, you actually get much more settlement. So doing proper presentation can help you very quickly with interpretation as well. So it is really worthwhile to be even systematic in your monitoring results presentation as well. Okay, and then one of my final things that I want to talk to you guys about. So, yeah, so this is my very good friend, or was my very good friend, DJ Hagen. And maybe some of you guys have met him at ICOLD, and here in South Africa, he was well known and well loved. And unfortunately, he passed away earlier this year, actually climbing into an unventilated manhole, all right, that was filled with toxic gases. So this is one of the things that people don't give enough attention, especially on the design, during the design of monitoring system. They don't give proper attention to the safety. And unfortunately, we lost DJ as a result. Okay. So this is just an example of such a manhole, a deep manhole. There's a flow gauge at the bottom, and the designers actually expect the operators to climb down there without any proper ventilation to actually go and take a measurement at the bottom. Okay, so it is really a serious issue that we have to give due attention, and I hope during my sort of involvement in dams that we will not have such a tragic event happening to us again. Okay, so ventilation, not just in manholes, ventilation in concrete dams is absolutely essential. And if it's unventilated, if you have to go in to do inspection or monitoring, you need to have appropriate monitoring equipment with you that can tell you whether it's safe to go into this unventilated environment or not. Okay. In general, other things, access as well, very important. Okay. I'll show you guys just now. I had the unfortunate, actually at Korabasa, I had the unfortunate thing happening to me as well. You need to have safe, the railings, proper chairs, upstairs, enough space, ease of access. Okay, so in my case, these openings were not, and I know I'm guilty, but I stepped into that opening. That opening, you should never have openings like that in your work environment where working personnel can actually injure themselves by stepping into the opening. Okay, so please, people, very, very important to actually look after the safety, especially of the operating personnel who's responsible for monitoring. Okay. My final thing that I wanted to just share with you guys, if you're not used, is our ICOLD family, our ICOLD surveillance family. So this is our technical committee, the ICOLD Technical Committee on Surveillance. For me, it's really a family, a group of people that are absolutely passionate about surveillance and doing the right thing. And if you guys, some of you visit ICOLD meetings, you will see some of us, and please come and visit us as observers in our technical committee if you have the time, all right? And through the years, we've actually produced, the committee has produced some really wonderful bulletins that will give you guidance on dam surveillance. This is the latest one that was published last year. We actually finished it like 5 years ago, but lessons learned from case histories. And then I just show you guys some other examples that you can, there's some really good examples of guide books that you can use. This monitoring of dam performance that is published by the ACE, very, very good book as well. John Dunnicliffe's book, and then the Corps of Engineers from the States as well produces very, very good information, publications on monitoring, okay, that you guys can access. So that is my my webinar. I'm sorry, I might have gone over like 5 or so minutes over my time.
Thank you, Louis, for highlighting the importance of why we need to look after our dams, and also why we need to take into consideration the safety of the operators of dams when we are doing our designs. You have highlighted that we should actually understand why we are doing the surveillance and monitoring, rather than just doing things because that's part of our job. And it's also highlighted that it's important that we actually understand what the data real recording is telling us, so that we're able to interpret it correctly. And lastly, thank you for passing on the knowledge and experience that you have to all of us. We really do appreciate it. And now we're opening the floor to questions. I did see that there were a few questions just now. Would the people asking questions like to ask the questions themselves, or we can read the questions out? You can just put up your hand, and then we will, direct. Oh no, sorry, it's not questions, is it? Sorry, it's Matea's presentation. Sorry, guys. Q&A is happening afterwards. My apologies.
No problem. My presentation will be really short, I promise, and then we'll go to the questions and answers. So I will provide just a few information about the Young Professionals Network and why we are even trying with this type of webinars, for example. So my name is Matea Klun. I'm a current chair of the Young Professionals Network at ICOLD. And the main goal of the Young Professionals Network within ICOLD is to target professionals in the early careers and try to provide knowledge transfer, mentoring opportunities, webinars like this, and to at least meet once a year at the ICOLD meeting. And since we are from all over the world, we are now also taking advantage of the networks available. So we're trying to have these online meetings and webinars so that we don't only see each other once a year, but also in between. Currently, in our Young Professionals Network family, there are 31 national committees who have formed their YPF or young professional networks. We are also trying to encourage, since there is more than 100 ICOLD countries, so there is still a lot of countries without young professionals network. So we are encouraging the formation of the new young professionals network. If you need any assistance or help on how to do this, contact us and we will provide some help to you, whatever you need. And I would just like to mention that there is 7 of us who are board members currently at the ICOLD. You can see here our pictures. Most of us will also attend the next meeting in Gothenburg. So if you see our faces there, come and talk to us. And I would just like to say that members of the board are voted and that our term of office is typically 3 years. We are trying to be as diverse as possible. Geographically, we're trying to involve the next organizers of the ICOLD conference to be on the board so that we have direct contact with the organizers of the main ICOLD events. And we are allowed to have 1 member per member country to be on the board. And now I am also announcing that in the Gothenburg there will be elections and that 2 positions on the board are open. So if you know a good candidate, if you believe that you're a good candidate, get the support from your national committee and send us your nomination. There is still 1 week of a time to do this. But be aware that you have to attend the meeting in Gothenburg in a few weeks, and there you'll have 1 minute to present yourself, and then all the young engineers, professionals who are attending that meeting have a right to vote. And if you get enough of the votes, then you are voted to be one of the members of the board, and you will be able to cooperate with us for the next 3 years. As I already mentioned, we are targeting all ICOLD events. We are targeting to get the young professionals involved. We are organizing virtual meetings, webinars, and trying to provide any network activities that are possible. And I would just like to highlight that the previous webinars are available online, either on our ICOLD, either on our LinkedIn group or on our YouTube channel. I will post these links also in the chat so you have direct access to them. And I would like to invite you to get involved. If you enjoy this webinar, if you want to have more webinars like this, if you know a good presenter, let us know. Or if you have an idea for the webinar, let us know. Here is our email, or you can post something in our LinkedIn group. We are very open. We try to be very informal. So we are just trying to get the young professionals involved. So you are more than welcome to contribute if you want to. And with this, I will conclude my presentation. And now it's really time for the questions and answers.
Thank you, Matea. I think it would be easier if I read out some of the questions that have already been posted. So the first question we have is from Paul. This is for Mikhail. The question is, nevertheless, first of all, it's congratulations, Mikhail, for the important initiative related to the dam safety in the Nile Basin. Nevertheless, my concern is about how to cooperate when your country is in conflict. Present example with Sudan.
Can I respond for that?
Sorry, the question is, Paul's concern is about how to cooperate when your country is in conflict.
Yeah, I understand the questions.
Oh, yes,
Can I respond?
yes.
Yeah. Actually, yes, I read the questions. First of all, Ethiopia and Sudan are not in conflict. They are in good relationship now. That has to be corrected first. And the other thing is now this managing dam safety in a transboundary is very complex matters. It's related to the water management issues. So what we did is we have tried to bring higher officials from the countries to discuss on the potential risks of dam failures and its consequences in downstream communities, as well as also the dam owners. So we provided them all the required capacity to understand about the risk of dam failures. So what we did is to create awareness and also build trust and confidence among the countries. So they're the one who decided on the cooperations and the agreements. So my understanding is that we did what we have expected to do as a regional business organization. Thank you.
Thank you. The next question we have is from Mary. I think this is for Louis. What is special about the Cahora Bassa Dam Safety Unit? Is it the structure or monitoring system?
Okay, so I just use that as an example. So it's actually the way since the beginning how monitoring has actually been handled. From the beginning, all the people involved have been properly trained to do proper monitoring. Okay, and they also have a proper process that they have been following since the early 1970s, and they still follow that. And that's the message that I was trying to actually, all the things that I wanted to actually, or a lot of the things that I wanted to highlight to you guys that I see at many dams that not adhere to, they actually adhere to. And as a result, the monitoring results that they've collected through the years are very good. And as a result, we actually don't have a lot of uncertainty about the monitoring information. So it helps us actually to manage the risk and the uncertainty of the dam. I hope that answers the question.
Are there anyone who wants to raise their hand to ask a question?
I believe that Clement has raised his hand. I have enabled his microphone so he can now ask.
Yes, I'm Clement, and my question is going to Lois, and it is concerning the embedded instruments that are embedded in the dams, and sometimes they are not able to work or they have stopped working. So what can you advise us to do? Is it that during the design, we do a parallel kind of instrumentation, or what is the best way? Because if the dam is still active and the instruments are embedded and they have stopped working, what else can we do? Thank you.
Okay, thank you, Clement. That's one of the real issues and questions that we that work in the monitoring side actually get every day if we work with older dams. So one of the questions that I want to pose to you is what's the answers that those instruments are actually giving you, and is it of essential importance that you actually get those answers? If it is, you need to actually think how you can actually maybe if you really believe it's essential that you get the answers from those instruments, then you will have to actually think, but it becomes very expensive if you start drilling. I must warn you, if you work with the embankment, and I see this many times, I see this, well, as I say, I work in Africa, and I see this many times in Africa. The old dam gets put out for a rehabilitation design, and one of the things that is put up there is actually replace all the piezometers, the standpipe piezometers, and even the vibrating wire piezometers. And then people actually start drilling into the embankment. You have to be very careful because you can actually cause more damage, and you can actually cause a failure if you don't do your drilling properly. So you actually have to really apply your mind if you think about replacing embedded materials, especially in earthfill. In concrete, it's normally just a question of cost, if I can put it that way. So I hope that gives you an answer. But it's one of those things that yeah, it's something that you have to, as I said in the beginning, I'm not going to give you recipes. So you have to apply your mind, but you also have to appreciate the risk for actually doing something.
Okay, and there is Odong Sam, who would like to ask a question. Please, you can unmute yourself.
Hello everyone, thanks for the opportunity. Mine is very simple. I already posted it in the chat, but maybe to clarify my question very well, we have these drainage sumps, and most of the time they are located at the basement of the floor. That means we have uplift pressure there too much, and then this leakage water always, it's constant, they always come. It's always the sump is always filled, and these sumps are also exposed to vibrations from the drainage pumps and all that, because these pumps are always powerful, and so they have a lot of vibration. So how best can you do the inspection in this drainage with that kind of atmosphere where the water is always coming in? Thank you.
I'm quickly trying to read what. Okay, so you're concerned about the concrete integrity of your drainage holes. What I can read from the chat, that is something to consider as well. But I mean, I would say the first thing that you should start is actually to, if it's important for you, yeah, is to actually monitor the flow that comes out of your holes. But in many cases, the designs that does not actually make provision for that. But to monitor the seepage that comes out of it, if there's no seepage, to even try and monitor the water levels. You can start off by just doing a subjective to see if there's water in there. If for 20 years your drainage hole were empty, and suddenly you actually have water filled in the drainage hole or water flowing out, then you would actually know that there's something actually going on in your foundation, and you can actually do some further investigation. So what I'm trying to say from a drainage point of view is, you need, in most cases, for most dams, you need to actually give more attention to your drainage holes, because most of the dams that I visited and seen in my life, there's no attention given to the drainage holes to do any monitoring on them. I hope that answers the question.
Thank you, Luis, for the answer. As I'm scrolling through the chat, I would like to ask you, there is a question about seismic monitoring, and I know that you have a lot of experience with vibration monitoring. Can you maybe say a few words about this?
I saw that one as well. So yes, and remember I said in the beginning, I'm only going to talk about manual measurements, because I was trying to highlight some principles. Some of you guys that know me, if you give me another 6 hours, I will still keep on talking about it. But I'm reading through that. I know, yes, okay, those passive seismic methods is maybe different from, Mattia, what me and you have looked at. And so I'm very interested in the ambient vibration monitoring, which basically is monitoring the dynamic behavior of the structures, not just arch dams, gravity dams, or concrete dams. But I think what that question, and I'm not sure how to pronounce the name, Anais, if I'm not mistaken. that is more about using seismic methods to get an idea of cracking and depth of cracks and discontinuities and things like that, if I'm not mistaken. So yes, that's maybe something that in general a lot of people are not aware about, and we don't do it often, but I have seen there has been publications about it. Maybe I'm wrong with the application, the question's application of that, but I know I've seen that particular methodology actually used for that. And my apologies that I didn't talk about that. As I say, I try to focus on simple things to highlight some very important basic concepts about monitoring.
Well, I just noted that maybe one of the future webinars could be devoted to this topic.
Okay.
And Alejandro Paul Huaman, I have enabled your microphone, so please. Mr. Alejandro Paul Huaman, I'm sorry if I'm not pronouncing your name correctly. Do you still want to ask the question? You can unmute yourself and. Okay, then in between I can look at the chat.
There is one question from Kingsley, and it's for Louis. How would you confirm or verify if calibrations have been done appropriately?
How do you confirm if the calibrations was done appropriately? You actually do the calibration measurement yourself. So that's why I was saying, if you actually go and do a dam safety evaluation, and you say a 5-yearly or 10-yearly one, you actually need to check and make sure that those calibrations are actually done properly. So that would be the best method. Most people don't do that.
Is there another question in the chat?
Yes.
Yes.
There is another one. This is for Mikhail. This is from Shao. Question for the first presenter. You said that Rusumo HPP is owned and shared across 3 countries. Does it mean there is a shared responsibility in maintaining the asset, e.g. undertaking ongoing dam safety surveillance and monitoring and maintenance works? How are these coordinated?
Janice, for who was this question?
Michael.
No, it's not for me. It's for the first presenter regarding about the Ugandan.
Oh, the first one. Sorry. Sorry. So sorry,
Wilberforce.
Apologies.
Okay.
You still with us?
Yes, thanks for the question. About that, the 3 countries made set up a joint or a special purpose vehicle, and that was the Rusumo Power Company Limited, and it's the one that led the implementation and will also jointly do the operation and maintenance, which includes dam safety and dam surveillance.
So the next one who raised their hand is, and I apologize for my pronunciation, but Kamogelope. I have enabled your microphone. You can speak now.
This question is for Louis Hattingh. Louis, in your presentation, you mentioned that I think it was Mozambique, they were able to maintain like a good record of monetary measurements, even though their country was in conflict, right? From your personal experience and your interaction with the dam staff, do you know why the attitude was so, and maybe if like there was incentive for the staff to keep like a good record of measurements of the dam? Thank you.
Yeah, as I said in my previous response to as well, is from the it was actually the designers and the people right in the beginning actually trained the people to do the right thing. They had the program and they had the right people, as I understand, for during that time. They actually the person responsible for the monitoring was actually the designer of the monitoring system as well. So it was a passionate person that wanted to do the right thing, and we can talk about that as well. I mean, it's one of the things that I showed you guys, Chris, in the beginning. He did some research on it, and it was one of his passions where he believed that actually when you appoint people to do monitoring at the dam, you should actually look at their brain profiles to actually make sure that you appoint the right person. You need a dedicated person. You don't need a highly qualified person, but you need the right person with the right attitude to actually do monitoring. So, and that's what through the years, they've been able to actually have that. So I wouldn't say there was incentives. Maybe it was an incentive to have a work, get paid for it and so forth. But I think it was just they were well trained. The system worked, and they were, it's one of the examples. So it's a good question that you're asking, but I know the guys very well, and they still follow the process and the procedures that was set for them in the 1970s, which is very good. I mean, it's one of the examples where they carry on with what you can say the previous generation was taught something, and they're actually carrying on with that. So, yeah, I hope that gives you some insight and answer to your question.
Thank you. Now I see that the question about international training has been already replied in the chat, and there is another raised hand from Mr. Lino. Let me enable your microphone. Okay, Mr. Lino, I have enabled your microphone. You can unmute yourself now.
No, I'm Michel Lino, president of ICOLD, and I would like to congratulate ICOLD Young Professional Forum for organizing this very informative webinar. Michel Abebe showed us the international cooperation along major rivers is a must in order to manage the safety of dams and also to provide an avenue to improve political cooperation, technical and political cooperation between the riparian countries. Louis gave us a brilliant presentation. I'm sure that it will motivate our younger colleagues to be involved in dam surveillance in their country. Thank you very much. I give back the floor to Mateja. Thank you.
Thank you, Mr. Lino. We are delighted that you attended the webinar, and thank you for the kind words. Yeah, we will try to organize more webinars, and I also have to say thank you to the presenters, to Mr. Hattingh, to Mr. Abebe, because it was inspirational to listen to both of you speak. And I'm actually really looking forward that in a few weeks I get to meet you in person also, and I'll have a chance to have more discussions with you. I always learn a lot.
It would be nice.
Yeah.
Thank you.
Do we have any other questions in the chat? Janice, have you?
I've looked through it. I do not see any other questions that have not been answered.
Then maybe we can slowly conclude this webinar. So,
Yes.
as I said, thank you for the presenters, and also thank you to Wilbur and Janice. You did a great job, and thank you for all you who attended. So, if anyone wishes to say any last words, please. You just waved. Okay, that's.
Thanks a lot for you guys, Mattia and Wilberforce, and Janice as well. Yeah. Well, actually, thank you, Wilberforce, because Wilberforce contacted me and chatted to me. So thanks for the opportunity to share some things with you guys, and I hope to see you in a couple of weeks in Sweden, and I hope to see a lot of you guys actually in Entebbe in Uganda at the Hydro Africa as well. Okay, so I saw there's some comments. You don't need to publish a paper. You only need to come and pay the registration fee and organize your visa and fly there if you're from another country. It's a beautiful country to go and visit. So yeah.
Great. I have only one last thing to say. Can Mr. Abebe also turn on his camera so I can make one print screen of all of the presenters? I forgot to do it before. I was too nervous on how the webinar will go.
Mattia, he is on. Mikkel's camera is on. I can see
it's
him.
on. Okay.
Yeah.
Okay, then it's a problem on my side. Can you then press a print screen?
I will do that. I will do that.
Great.
I've done that.
Done. Okay. And then, yeah, thanks to all of you. It was really a pleasure, and see you all soon. And now we'll slowly close the webinar, and the recording will be available. Let me just redact it a bit. So yeah,
Okay.
thank you, and see
Thanks
you soon.
a lot. See you guys.
Thank you,
Bye.
everyone.